So again, do you guys have a question or clarification?
None po.
None.
None, sir.
All right then. Okay, so if you guys do not have a question, so let's now proceed to the next one. All right. So here's the inference form, wherein the above mentioned P1, P2, or up to P10 or P100, those are our hypothesis or premises. And then once you can see this horizontal line, which is separated from the hypothesis or premises, this is now our conclusion. So mostly, this conclusion is only one variable or two variables. Okay, but mostly one variable only. Okay, so again, the separator here, so this is your first hypothesis. The separator here is the and or the conjunction symbol. So we read this one as P1 and P2 and so on and so forth. Okay. Conditional, so this conditional here as actually equal to this horizontal line or equal. Okay. So P1, P2 up to Pn is equal to letter P. All right, so that's how you read this inference form. Okay. So here are the basic rules of inference. So again, in hypothesis, we're always assuming that the value, okay, the initial value of your hypothesis is always true. So if P is true, then P will always be true. Okay. So in hypothesis, we assume that this one is true, then we can conclude now that this letter P is really true. Okay. So this will only be affected, or this will only become false if there is other, okay, if there is other uh, hypothesis that will make this one false. But since there is no other hypothesis aside from this one, then you could assume that this one is the conclusion. So here are the other examples. So the same with this one. So Q is always true. So we could conclude that this one is true. And then this negated R is always true. So we could conclude now that this one is always true. So basically, you can just simply copy this one, okay, regardless of the symbol or the negated, or if there is a negated or there is no negated symbol. Okay, so the assumption or the value of this one is always true. Okay, same with this one. Okay, just have a negated symbol. All right, so those are the laws or rules for identity. Okay, so next we have here conjunction and conjunctive simplification. So first is conjunction. So again, we read this one as P and Q. Okay, so in here, there are no other hypotheses which will make this one false and then this one also false. So we assume, okay, that they are true. So we could say that P and Q is true. Simple as that. Okay. So here are the other forms or other format. So we have here P and Q, okay, wherein there are no other hypothesis that is saying that P is false or Q is false. Then we could just simply say that P is true. So as you can see right here, we have two possible results. So if you have this kind of expression, and then assuming that their values is true, then you can answer P or Q. Okay. So either of those two actually. So they are both correct. Okay. Since their values are true. Okay. So it will not change our result as being or becoming true. So were you guys able to follow up to this point?
Yes, sir.
Yes, sir.
Yes, sir.
So maybe at first this one is quite shocking or confusing because maybe this is your first time learning about rules of inference. So we'll be having, don't worry, we'll be having examples on this one on how to come up with such conclusion. Okay. So next we have here disjunction. Okay. So as you can see right here, this one is P. Okay. And then we could say that this P is concluded as P or Q. So this will not change the result, nevertheless, of the value of Q, because in OR, if there is one true, then the entire result is already true. So this is just a way to see that, regardless of the value of our Q, the result is still true. So that is why they've shown here that the conclusion is P or Q, okay, instead of saying P only. Right? Or vice versa, we could say that if this one is Q, then we could say Q or P. Okay, because we have already assumed that this letter P is always true. Okay, so here are the other examples for disjunctive syllogism. So we have here P or Q. So again, the value for P or Q is already true. So P is true, Q is true. And then there is another hypothesis that came out wherein it is saying that our P from our first hypothesis is actually false, right? So again, in rules of inferencing, our result should be always true. Okay, so in here, we should put here Q because we have already know that P is actually false. So we should conclude that the result must be Q because this one is already true. Okay, so the same with this one. In here, knowing that P or Q is always true, but then there is another hypothesis came up wherein it is saying that this hypothesis or this letter P is actually, this letter Q is actually false. Okay, so since we already know that this letter Q is false, then we have to answer P. Since in inference, we have to make a tautology result. Okay, so that is why we have an answer or conclusion here P, and then we have a conclusion here Q. All right. So were you guys able to follow at least 50%?
Yes, sir.
Yes, sir.
Yes,
So
sir.
here's the tip and trick. So your conclusion must always make the entire expression true. Okay. So that is your key points on how to identify what would be the conclusion. Okay. So that's how we come up with Q or P. All right, so we have another two rules of inferencing here. We have the modus ponens and then the modus tollens. So modus ponens is actually a Latin word for meaning affirmative mode. And then for modus tollens, meaning denial mode. Okay, so modus ponens first. So in here, initially our value of P is already true. Okay, and then we have another hypothesis here wherein P conditional Q. Okay, so in here, okay, there's actually no tricky part in here since by default letter P is true, Q is also true. So if we can see this kind of statement, then the result is always the conclusion. Okay. So again, we have two hypotheses, which is just the same variable. And then whatever is the result, then that would be our final answer, which is true. Okay. And then we have another format here for modus ponens. We have here negated P, conditional Q. So again, assuming that negated P is true, conditional Q is also true. Okay. And then it is saying that negated P is really true. Okay. So do not be confused with this negated. So we're just saying that this negated P is actually really true, okay? Just by showing another negated P. So from here, we could see that those hypotheses is equal with the conclusion since we have assumed that they are actually true, okay? So quite tricky when it comes to having negated symbol. But then again, in hypothesis, we always assume that they are true. So, for example, this one is true already, but we have here another. Okay, this is a good example. I'll give you guys a scenario. So, so from here, this is the result, right? But then again, if you have There you go. How to make this one thicker. All right. So if we have this kind of format or expression, so assuming that negated P conditional Q is true, so this one is true, and then the other one is true. But then again, there's another hypothesis came out wherein it is saying that this negated P is actually false, okay, because we have a different result in here, wherein letter P is actually false. So false conditional Q, okay, so since our hypothesis is already false, then we have to copy the last one, which is true, since we want to have a result of true, okay? So yeah, anyway, vice versa, either this one is actually true or false as long as the conclusion is true. If you can recall the truth table of conditional, nevertheless of the value of the hypothesis, as long as you have a true conclusion, the result will always be true. Okay, so that is why if we have this kind of setup, the answer is still Q. So were you guys able to follow? Can you guys get what I'm trying to say?
Clear, sir.
All right, so I really hope so. So again, if this is true, you will still answer this one. If this one is false, then you will still answer this one as your conclusion. All right, anyway, that's it for modus ponens. And then the next one is modus tollens. So we have here P conditional Q. So assuming that P is true and then Q is true. Okay. And then we have another hypothesis here wherein it's saying that this Q is actually false. Okay. So if that is the case, this one is actually in denial mode. Okay. So if we have this scenario in denial mode, we have to negate the hypothesis. So your result in here will be your hypothesis, but in a negated manner. Okay? So that is why from positive, it will become negative. So the same with this one, assuming that negated R is true, and then S is also true, and then we've proven that this S is actually false. So if we have this kind of setup, this one is in denial mode again. So we have to negate your hypothesis as your conclusion. Okay, so from negated R, it will become positive R, right? So that's it for modus tollens. Okay, so the only result that will make the conclusion as negated or positive is in a form of modus tollens. The rest, 1 to 5, so all of them are positive, depending on the construction. So did you guys get or get the modus tollens? Or just a little? Hello, are you guys still there?
Gets po, sir.
All right, that's good.
Yes,
Sir.
sir.
The only advice is just memorize this one. Okay, so if you can see this kind of format, then you have to negate your hypothesis. Same with this one. This kind of format, then you have to negate your hypothesis. Anyway, here are the other uh, inference rules. We have here the conjunction, so you could read this one again as P and Q, and then this one as Q only, okay, since both of those are just true. And then in here, so this one is modus tollens. So we have a negated conclusion, so you have to negate your hypothesis as your result. And then we have here end elimination or simplification. So P and Q is concluded as P. So it could be this one or this one. So out of those two, they are both correct. So you can answer P or Q, right? Then we have here disjunction. And disjunction, how did this happen again? P or Q. yeah, just remember. So in disjunction, so in here it is just saying that you can say that this P could be as a result as P or Q. Okay, because regardless of the value of your Q, P is always true. So you can have this kind of answer or in this manner. So the same with Q. So you can answer P or Q since Q is already true. Okay, and then as you all know in conjunction, I mean in disjunction, if there is already one true, then the entire statement is already true, right? And then here are the others. We have here hypothetical syllogism. So in here, I cannot give you guys a scenario, but if you're going to read this one, so your hypothesis here is P, okay? And then your conclusion is Q. But then again, this conclusion became hypothesis and then we'll come up with another conclusion. So if you can see, or if you will see this kind of scenario on the future secrets, so you can just disregard this two in the middle, which is letter Q. Okay, so from conclusion to hypothesis. So you could say that this one is equal or equivalent to P conditional R. Okay, so this one is hypothetical. So instead of uh, you know jumping with another conclusion, so we've just come up with the first hypothesis and then come up with the final conclusion. So yeah, just memorize this one. Okay, so we call this one hypothetical syllogism. Then we have here disjunctive syllogism. So we have P or Q, and then P is already false, so we have to answer letter Q. And then another one is P or Q, and then we have proven, or we have here another hypothesis which is saying that Q is actually false, so we have to answer letter P. Okay, and then we have here contradiction, wherein again this one is already true, but this one is already proven false. So we don't have a choice but to answer. Sorry, this one is actually modus tollens. Okay, so if we have a false or a false conclusion, we have to negate the hypothesis. Right? So that is why we have here a positive P. Wherein we call this one contradiction. All right, so that's it for the like a summary for inference rules for proposition. So do you guys have any clarification regarding with this one?
Answer.
Right. So since you have your copy with you, this inference rule summary, so I guess you'll be having a hard time in answering your secret since you don't need to memorize those tables or rules anymore. Right. So let's have an inference example. So it says here, use the truth table to prove the following. So we have here the inference format. So this one is actually also known as the modus ponens, if you guys can recall. So let S be the statement wherein from here you can construct this inference format into this. So again, how do we read this one? So P separated by this another hypothesis is actually an invisible N, which is now this one. Okay, and then we have P conditional Q, which is now this one. And then this bracket here is just the conclusion, okay, or the conditional. Okay. So this one now is equal with this expression. And then from here, we have to come up with a truth table, okay, which is now this one. All right. So we will not answer this one now one by one. So I'll just leave this one to you as your self-study or self-verification later on once we're done with our discussion. So yeah, so assuming that this is the result that we come up with this one. Okay, so we have here tautology. So we have now proven that this inference format or this expression is a true inference or for this one true expression, okay, with the use of inferencing rules. Okay. However, if we can or we have come up with true, false, true, true, okay, meaning this format or this expression is not legitimately done by the inferencing rule. Okay, maybe you did another way of solving things, which is not included or which is not really part of the inference rule. Okay, so we call that one modus padus. So we will discuss that one later on. But for now, let's have another example or exercise rather. So prove that P conditional Q, not Q, is equal to not P. Okay. So from here, we can actually copy this entire hypothesis through here in our solution. And then as you can see right here, we didn't change anything, okay, aside from this one, right? So why did we convert this one into this one? Okay, because we are trying to prove that this hypothesis is equal to this conclusion. So using the laws of logic, so looking back on your laws of logic, we have contrapositive wherein P conditional Q is equal to negated Q conditional not P, which is a contrapositive. And then from here, we can now evaluate this one, okay, into negated P. So as you can see right here, we have here true negated Q and then conditional true not P. And then we have proved that this one is actually true. So from here, we could say that this one is equal to negated P. So how did we come up with that result? So just go back to modus ponens. So from here, this one is true, this one is still true. So that is why we have come up with this Q. So the same with this one. Whatever is the value of this one, so negated or not negated, then just copy that one as it is. All right, so that's how we prove such inferencing format using the laws of logic. Or actually, you can just go straight in here. So from here, this one is actually modus tollens, right? Do you guys agree? This one is modus tollens. Or no? So go back with your own copy. So yes, P and then Q is true, but in here we have proven that Q is actually false. Wherein this one is in a denial mode. And if we are in a denial mode, so we will answer or we will conclude the hypothesis, but in a negated format. So that is why we have here negated. So were you guys able to follow this one?
Yes, sir.
Yes, sir.
Really? Okay. So once we're done with our discussions, I would like you guys to practice. Okay. So you can find another examples on the internet. So try to, get some of those and then try to do that one on your own. So using your own approach. So in here, you can have two approach. So just by converting this one into a contrapositive and then come up with the negated P. Or you can just go straight just by applying the modus tollens, okay, which is now also equal to negated P. Right? So yeah. Another one is this kind of inference format. So we have to prove that this hypothesis is actually equal with this conclusion P. So again, just copy the hypothesis as it is and put it into your solution. And then the next thing that you need to find is if you can eliminate other variables from another hypothesis. As you can see right here, we have this R and then R not Q. So we can actually combine those two into one. Okay. So in here, we've applied modus ponens. Okay. So we have proven that this one is actually true. So yeah, if it's modus ponens, that then just copy the conclusion as it is. So we have a result here of negated Q. And then from here, we have P or Q and then not Q. So again, this hypothesis is already proven true, but there is another hypothesis came out wherein it is saying that this Q is actually false. So from here, we have to get the true one, or the true value, which is letter P. So that is why this expression is equal to this letter P. So did you guys get it?
Yes, sir.
All right.
Yes,
So
sir.
if you didn't get this one, then I suggest to go back on the inferencing rule. So maybe just memorize some of those or try to understand those, and then go back in here once you're done understanding how we've come up with such result or conclusion. Anyway, so next one here is number 2. Prove that this expression is equal to S. Right? So from here, we've arranged this one now in a manner that we can eliminate most of the variables. Wherein we've got this one first, P or Q, and then Q conditional R. And then the next one is R conditional S, and then the last one is P. Okay, so this one first, P conditional Q, and then Q conditional R. So from here, this one fits perfectly for the hyposyllogism, okay, which is this one, wherein we can disregard the conclusion and then the hypothesis. All right, so just go straight from the first hypothesis and then the last conclusion, which is P conditional R. And then from here, you can just copy this one into this one. And then as you can see right here, again, this one fits perfectly for our hyposyllogism, wherein we can disregard this letter R and then just come up with P conditional S, right, which is not this one. And then from here, you can just copy this one and then put it here. And then you can apply here modus ponens. So this hypothesis is already proven too. So you can just simply copy the conclusion as it is as your final answer. Are you guys able to follow? So two hyposyllogism, and then the last one is modus ponens. So is there someone who's confused to this point? All right, so I'm assuming that none, okay, since no one is answering. Anyway, so let's have this last example. So prove that this expression is equal to negated P, right? So again, just put or just get all of those hypotheses and then put it in here, and then find hypothesis wherein you can eliminate 3 variables into 1 or 2 variables into 1. So in here, as you can see, we have true value for U and then true value for not X. And then somehow we have proven that this U is actually false. So we have to copy the true value, which is the negated X. Okay. And then from here, we can now combine this one into this one. So again, we have assumed that this X and then negated S is true, but then there is another hypothesis saying that this X is actually false. Okay, so all we need to do is just copy the true one, which is the negated S. And then from here, we can just combine this one into this negated S. Just put this R conditional S below. And then this R conditional S is already proven to be true. But then again, there is another hypothesis saying that this S is actually false. So modus tollens. So if we have this kind of denial mode, so just negate the hypothesis. So from positive R into negated R. And then this negated R can be deduced by combining this into P conditional R. So just put this one into here. And then assuming that this P conditional R is already proven to be true. But then again, we have another hypothesis saying that this R is actually false. So if we have a false conclusion, then this one is again modus tollens. Okay. So in modus tollens, we'll just copy the hypothesis and then negate its value. So from positive, it will become negative. So in here, we have now proven that this or those hypotheses is really equal with negated p. Okay, so here are the steps that we have or that we did. So first one is or elimination, and then the next one is or elimination, and then the last two is modus tollens. Okay. 1, 2, 3, 4. So first step, second step, third step, and then fourth step. Were you guys able to follow so far or no?
Medyo, sir.
Medyo, sir.
Medyo. Okay. So I'll give you guys a minute, okay, to analyze this one. Okay. So browse back using your own copy if you need. So here are the steps that we have applied. So again, if you have a question, don't be shy to ask.
Sir, question, sir.
Yes.
Do on making the solution, sir, do we need to start from bottom to top
Bottom to top.
to prove the
Actually, there is no proper arrangement on your hypothesis. Okay, so in here you can just simply put this P conditional R into the last one, R conditional S to the first one, is X or not S to the second one. So that's up to you on how you will arrange such expression. It's just that just find, okay, find a hypothesis that you can think that you can reduce into a smaller variable. Like, for example, this one, P conditional R and then R conditional S. This one can actually be done using hypothetical syllogism. Okay, so you can actually come up with P conditional S. But take note, you're trying to prove that this one is equal to not P. Okay, so if your result, okay, is not equal to not P, then your ways of doing things or eliminating things is not correct. So you might want to try to change your approach. Okay. So maybe that is the
okay,
reason.
sir. Thank you, sir.
Okay. So how about the others? All right. So since we now only have 30 seconds, I guess, so we will just